Welcome to this video on trig functions. Right then, now when we did core 2, you will remember that we use trig functions like tan, a bit bigger, tan equals sine over cos, or sine squared theta plus cos squared theta equals 1. Now then, we're going to use the sine squared theta plus cos squared theta one for a second. And we're going to divide the whole lot by sine squared theta, which gives us 1 plus cos squared theta over sine squared theta equals 1 over sine squared theta, which equals 1 plus, well, cos over sine is tan. It's 1 over tan, and 1 over tan can be written as cot. So we've got cot squared x equals 1 over sine squared, and 1 over sine is written as cosec, so it's cosec squared. Conversely, if we have sine squared theta plus cos squared theta equals 1 again, but this time divide the whole lot by cos squared theta, then we end up with sine squared theta over cos squared theta plus 1 equals 1 over cos squared theta equals tan squared theta plus 1 equals sec squared. So these are the two new trig identities that you need to know for C3. Now, just as a quick bit of background, cot equals 1 over tan, sec equals 1 over cos, and tan equals 1 over, sorry, written that wrong, that should be cot, cosec equals 1 over sine. I shall get them right. And these are kind of the new trig identities that you need to learn for C3. They're fairly easy to remember due to the third letter rule. Cot, T for tan, sec, C for cos, cosec, S for sine. Now, I'm not going to do much that's actually particularly difficult here because most of this stuff is fairly straightforward. But what I am going to do is do a question just to kind of show you what you will need to do for this. So we're going to take the question 2 cosec squared x equals 1 plus 3 cot x. Now then, remember that we can write cosec as 1 plus cot. So we're going to write that as 2 lots of 1 plus cot squared x equals 1 plus 3 cot x. And then we can write that as 2 plus 2 cot x, or 2 cot squared x should I say, equals 1 plus 3 cot x. Bring everything over, and you've got 2 cot squared x minus 3 cot x, bring the 1 over as well, plus 1, and that all equals 0. Now you're probably looking at it and thinking this is horrible, but remember when we did the trig identities in core 2 and you used to be able to put them in terms of a quadratic equation? So that's exactly what we're going to do here. We're going to use the same trick we did in C2 as well. We're going to go and say that u equals cot x, so it's 2u squared minus 3u plus 1, which goes to 2u minus 1u minus 1. Therefore, we know that u equals 0.5 and u equals 1. So now effectively what we know is that cot x equals 1 and cot equals, or cot x equals 0.5. Now, I'm not going to go and prove all the solutions for you because you can all plug values into a calculator, I don't deny that. What I will say is that cot, remember, is 1 over tan, effectively x equals 1. So therefore you can write it as just tan x equals 1, and then obviously you can do inverse tan. And the same here, you can just do it as 1 over tan x equals 0.5. You can change it so it's tan x equals 1/2, and then you can just, and then you inverse tan, and there you found your solutions. Thank you for listening.